All right, we're going to start looking at 6a. 6a, we are simplifying some trigonometric expressions. Eventually, we're going to be simplifying equations using trigonometric expressions and what we're learning here. So right now, we're just getting used to our different trig identities. We have our reference sheet, so I'll show that real quick. This reference sheet you can use on a test. I don't expect you to have them all memorized. So I have this as well with me. So at the top, a couple things that I wanted to note before we get into our notes is if I have cosine of x, you might also see it as cosine of t, where we change the variable. It doesn't matter if it's x or t. Another pretty common thing is if we use theta. So it is kind of like an oval with a belt on. So this is pronounced or spelled theta, pronounced like that. It's just another way to represent an unknown, usually angle measurement. But really any variable could go there. So when we're doing some of these, if you notice that it's not an x and it's a different variable or it's theta, it all means the same thing. The variable or theta just represents something we don't know. And again, it could be sine or tangent. Either way, x, t, theta, any variable will work. For the second part here, when we have sine of x and we want that to be squared, this is what we want, but how we write it is sine squared x. So we bring that exponent in between. That way we don't have to have parentheses. And if we wrote it like this without parentheses, it actually looks like just the x is being squared, not the entire quantity being squared. So we don't do this. And that is why mathematicians put the exponent in between the sign and the variable. So these are mathematically equivalent. Those are the same. So underneath that we have another box. This box are the different methods that we can use to simplify some expressions. And we're going to be labeling some of them in our notes. So for example 1, it says simplify the expression tangent of x over secant of x. So what we're going to do to solve this is I actually want to use my identities and rewrite tangent and rewrite secant using my reference sheet. So until you get comfortable with it, we should always have this present. So I know tangent is equal to sine over cosine, so I'm going to start with that. So my numerator is going to be sine of x over cosine of x, because that's what tangent can be rewritten as. My denominator is secant, so I know secant is the same thing as 1 over cosine, so I'm going to rewrite my denominator as 1 over cosine. Sometimes that is the biggest thing that can help, is rewriting things in terms of sine and cosine. So if you have a tangent or you have a secant or a cosecant, rewriting it using sine and cosine might reveal the next step or kind of allow you to see what the next step would be where it might not be as visible before. So I have some fractions inside of a fraction. I don't want that, so I'm going to multiply by my reciprocal. When I do that, I want to make sure that I flip this. So I still have my sine of x over my cosine of x, but that denominator is coming up and multiplying, and my cosine is now in my numerator, and the 1 is in the denominator because I have to flip it. Now that it's set up like this, because my two fractions are being multiplied, I know that my cosines will cancel because 1's in the numerator, 1's in the denominator. So I have sine of x over 1, which is just sine of x. So we simplified this expression into just sine of x. We did it. So on the side for this one, I want you to write, this is a fine, well, let me use a different color. I don't want it to bleed through. We ended up using our identities. That way, when you're going through practice problems, if you see one similar, you can be like, oh, we used identities. Maybe I should start with that step as well. So moving on to example 2. It says simplify the expression cosine of x minus cosine of x times sine of x squared. When I start reading these off, I will eventually stop saying the variables and I'll just say cosine minus cosine times sine squared, just as a shorthand type of thing. So here, it's already written in terms of sine and cosine. I don't have a tangent or secant that I can change out, so I can't really use the same thing that we did in example 1. I also know that I have 2 terms. I have my first term and I have my second term, and they are broken up by that minus sign. I also notice that I have a cosine in both of my terms. So I'm going to factor out a cosine. So that means I have to bring that out in front of parentheses. And then I'm going to write what's left over when we take that cosine out. So for our first term, if I had cosine of x, I factored it out, I don't have any more left, but technically it would still be 1, because what we're doing is we're taking that term and we're dividing it by cosine of x. Well, that turns to 1, so I'm going to put a 1 inside my parentheses. My minus sign is still here. For my second term, I'm going to divide by cosine because that's what I'm doing when I factor it out. So this cosine is no longer there. I still have my sine squared. So I have cosine times a quantity, 1 minus sine squared, and my quantity. Anytime we have a 1 with a plus or minus and something's being squared, I want you to start recognizing this as a red flag. A green flag, I should say, not a red flag. Because it's probably on our reference sheet. So I'm going to get my reference sheet out. I'm looking for 1 minus sine squared. So towards the bottom, I have 1 minus cosine squared. But over here, I have 1 minus sine squared. So I know that this 1 minus sine squared can be rewritten as cosine squared because they're equal to each other. So going back to my notes, I have my cosine of x still out in front, but the part inside parentheses turns into cosine squared. So if I have cosine times cosine squared, that's kind of the same thing as x times x squared. Well, I have 1 here, I have 2 here, so I have 3 altogether. So I have cosine cubed, and that is my final answer. So for this one on the side, what we ended up doing is we factored, and so I'm going to make a little note for that. All right, so example 3, it says simplify the expression secant of x minus cosine of x all over secant of x. So looking at this, we have subtraction in my numerator. This allows me to break this fraction up where I have my secant of x in the numerator of one fraction, my cosine of x as a numerator in my other fraction, and my denominator will be under both of them. I can only split the fraction up if the addition or subtraction is in the numerator. So let's go ahead and start with that. I have secant of x over secant of x, and then I'm subtracting cosine of x over secant of x. So something I notice is that we have secant of x over secant of x. If I have the same thing, those will cancel out to 1. So I can rewrite this as 1 minus cosine over secant. I'm still not simplified because I want to get it down to just one tiny expression. So I want to rewrite secant in terms of sine or cosine. I know secant is 1 over cosine, so I have 1 minus, and then in this denominator I have 1 over cosine. I don't want a fraction inside of a fraction, so I'm going to take this and I'm going to flip and multiply. So it'll turn into cosine of x over 1. Because when I flip and multiply, it's no longer down here. So I could like cover that up. And I'm going to multiply my cosine times cosine, and then my denominator times the 1, which is just 1. So I'm going to go up over here. This one didn't go away, so I still have that 1 out in front. And then remember, this part is covered up, so I'm going to cover it up with my finger. I know it's at the bottom there. And I'm doing cosine of x times cosine of x, which would be cosine of x squared. 1 minus cosine squared is on your reference sheet, and that is equal to sine squared. And we simplified that one. All right, we're going to flip the page. So looking at example 4, if you want to try this one on your own first, that's great. You can go ahead and pause the video here and then come back. I am going to go through it, but I'm going to go through this one a little bit quicker. So this one is very similar to example 1. I want to rewrite these in terms of sine and cosine. Secant in my numerator is 1 over cosine. Cosecant in my denominator is 1 over sine. I don't want a fraction instead of a fraction, so I'm going to flip and multiply. So I have 1 over cosine times, I flip it, so it's sine of x over 1. When I multiply those straight across, I get sine of x over cosine of x. And I know sine of x over cosine of x is tangent of x. All right, so for example 5, I do want you to try this one on your own. So if you could look at the problem, I want you to look at your reference sheet, see if there's anything that matches, pause the video, try it, and then come back and see how I do it. All right, so in my numerator for this one, I have 1 minus sine squared. That is on my reference sheet. 1 minus sine squared is equal to cosine squared. So I'm going to rewrite this as cosine squared over cosine. Well, if I have 2 cosines in my numerator and I have 1 in my denominator, I can cancel out the 1 from the denominator with 1 of the numerators, so I still have 1 left over. So my final answer is cosine of x. So that one went a lot faster than the one right before it, but we did it. All right, so for example 6, this will be the last one that we go through in this video. It says simplify the expression. We have sine cubed plus sine times cosine squared. So this one, I noticed that I have 2 terms. I don't have a fraction. I have addition between my 2 terms, and they're already written in sine or cosine. This one, if you don't notice anything or don't have ideas, I think it looks similar to example 2. So in example 2, we also had 2 terms, and we noticed what was in both terms and factored that out. Here, in both my terms, I have at least 1 sine in both terms, so I'm going to factor out sine of x. So I'm going to bring out just 1, because in my second term I only have 1, so I can't take out more than that. So if I had sine cubed, I took 1 out, I would still have 2 left over, so that would be sine squared. For my second term, I had sine times cosine squared. Well, if I'm factoring out the sine, I just have that cosine squared that's left over. Now from here, I know that sine squared plus cosine squared is one of my identities on my reference sheet. Sine squared plus cosine squared is equal to 1, so I can rewrite that as 1. And if I have sine of x times 1, that is just sine of x. And we did it!